In this section, I will teach you two-way classification of data. Two-way analysis of data variance is an extension of one-way classification. It has two different categories. The main difference between one-way classification is in this two-way classification has two independent variables. In the case of one-way classification, it has only one independent variable. But in this case, we have two independent variables. And we can proceed procedure of two-way classification. First, we have null hypothesis. In this case, we have null hypothesis, two assumptions. One is means of column are equal and other is means of row are equal. So two-way classification's null hypothesis is one is means of columns are equal and other is means of rows are equal. This is the first step of two-way classification. Next is compute the value of t. T is sum of all observations or all values in the given table. T is sum of all observations. Next, you find SST. SST is sum of squares of observations minus t square by n. T is given observation. We take a given observations and all observations add it. That value is t. SST means you take all observations and each observations we square it and add it. We have 1, 2, 3, 4, 5 observations. So you can square it 1 square, 2 square, 3 square, 4 square, 5 square and add. This is the example. So sum of the square of observation means you take all observations and square and add it. Sum of squares of observations minus t square by n. This value is SST. So we get what is the t? And n is total observations. N is total observations. So we got SST. Next is you find SSC. Sum of square, total square aanu. Here SSC means sum of square of observation is SST. Here SSC means sum of square of columns. So you take a column square, you take divided by n1 plus next column sum square divided by n2. So how many columns you take? That column's total square divided by number of observations in that column. Summation x2. Second column you take a sum of that second column and square divided by number of elements in second column, etc. minus t square by n. This is the value SSC. Next, you find SSR. This is the difference between one-way classification. We didn't find SSR in one-way classification. But two-way classification, we need to find SSR. SSR means sum of first row you take. Here, row square divided by number of rows. Plus summation of x2 is second row sum square divided by n2. Next, you take x3 is a third row sum square divided by n3, etc. t square by n. So first you find t value, next SST, next SSC. Here sigma x1 is column sum. Sigma x1 is column sum. First column sum. Sigma x2 is second column sum. Sigma x2 square, etc. Here SSR. In the case of SSR, sigma x1 is first row sum. Sigma x2 is second row sum. In this way, continue. Next, you find SSE. SSE is SST minus SSC minus SSR. SST is sum of square of all observation. You already found. SSC is sum of square of column. SSR is sum of square of row. So you find a difference from SST to SSC and SSR. So SSE is SST minus SSC minus SSR. Next you find, seventh step is you find MSC. MSC is mean square, mean column square, mean square of column. MSC equal to SSC divided by C minus 1. C is number of columns. SSC already find. C is number of columns minus 1. This is the MSC. Next MSR. MSR is SSR divided by R minus 1. You already found SSR. R is number of rows minus 1. Next MSE. E is SSE divided by C minus 1 into R minus 1. SSE is C minus 1 into R minus 1. So you found mean square column, mean square row, mean square estimation. So first we find out 3 sum of squares, SST, SSC, SSR. Next you found MSC, MSR, MSE, mean square values. Next you find calculated F ratio. F ratio is, one is FC and other is FR. Calculated column F ratio and calculated row F ratio. Column F ratio is MSC divided by MSE and row F ratio is MSR divided by MSE. So we got column F ratio and row F ratio. Next, you need to calculate table value of Next, we need to calculate table value of FC and FR. column F ratio and row F ratio. So first we need a degree of freedom for FC is C minus 1. C is number of columns. C minus 1 into R minus 1. This is the degree of freedom of column. C minus 1 comma C minus 1 into R minus 1. Next, degree of freedom of for FR, row F ratio. R minus 1 comma C minus 1 into R minus 1. This is the degree of freedom of row F ratio. Then you find level of significance. You can take a 5%, 0.05. Otherwise, problem has given. Problem has given means you take that value. Otherwise, you can take 5%. 5% means 0.05 level of significance. Then you found the degree of freedom of FC is C minus 1 comma C minus 1 into R minus 1, and corresponding to level of significance you found the table value of FC and FR. Next we will compare the calculated value of FC less than table value of FC, then our hypothesis is accepted. Column related hypothesis is accepted. That means column means mean of columns. Means of columns are equal. That is alpha 1, alpha 2, etc. B means of column. So we can say alpha 1 equal to alpha 2 equal to etc. Next, if calculated row F ratio is less than table value of FR, then we can conclude means of row is equal. That is beta 1, beta 2, etc. B means of row beta 1 equal to beta 2 equal to etc. This is the conclusion. So first I briefly once more I say, first you found one assumption. Assumption is means of columns are equal and means of row are equal. In this case, two assumptions. We have two assumptions. Then you found the t value. T is SST and a square sum of square of total, sum of square of column, sum of square of row. These SSC, SST, SSC, SSR, these three values first you found. Next, mean square column, mean square row and MSE. These three values you found. Next, you can find calculated F ratio in the basis of column F ratio and calculated row F ratio. Next, you can find the tabled value of FC and FR. So degree of freedom is C minus 1 comma C minus 1 R minus 1. Degree of freedom of FC and degree of freedom of FR is R minus 1, C minus 1, R minus 1. Then you find the tabled value, calculated value less than tabled value. So our column means are equal. and calculated value of FR and tabled less than tabled value of FR, then we can say row means are equal. Next we can draw ANOVA table. First, source of variation. Next, sum of square, degree of freedom, and mean of square, the F values. 1. Between column, between rows, residual. Between column is SSC, between row is SSR, and residual is SSE, and total is SST. Degree of freedom of column is C minus 1, here R minus 1, and residue is C minus 1 cross R minus 1. Total degree of freedom is N minus 1. Then between column mean of square is MSC, between row mean of square is MSR, and between residual MSE. And you can found FC and FR. FC is a F ratio of column and FR is a F ratio of row. This is the procedure of two-way classification of ANOVA.